Okay, here's another example for 11.1. So extra example number 2. So really this is like the third example I've given. I've just broken them up. Okay, if I look at this, where do I start if I want to know if where this function is increasing or decreasing? Derivative. I mean, a lot of what we do the derivative first, right? So we start with the derivative. So we have a chain rule here because you have something to a power, and that isn't just one value in there. So what did we do for the chain rule for this? Well, we did the outside first, and then we took the derivative of the inside. I'm not saying that very good. So basically the 1/3 comes down, you keep everything the same, and then you subtract 1, which would give you -2/3, and then you have to times it by the derivative of the inside, which is a -1. Okay, because the 1 goes to 0, and then the derivative of -x is -1, right? So if I simplify this, I should know that this -2/3 can be moved to the denominator. So what would this look like? Well, you'd have the -1 still on top, -1 times 1, -1. You'd have a 3 on the bottom, because it's already on the bottom, but now 1 minus x to the 2/3 should also be on the bottom to get rid of that negative in the exponent place. Kind of looks like my swirl there. It looks a little weird, but just a 2/3. Okay, so now we have to find our critical values, our partition values, and that's where this equals 0. Okay, well, we can't have a 1 in the denominator because what happens? 0 to the 2/3 is 0. 0 times 3 is 0. I'd get a 0 in the denominator. So this is really my first example that has a partition number, which is at, or an undefined, which is at x equals 1. Okay, it's a partition or critical value. I mean, you can call them all partition values or critical values. Like, you just need to know some are from undefined and some are from 0. Okay, now if I let this equal 0 and solved, this would all times up by 0, and I would get 0 equals -1. So there's not a solution. So this can't equal 0 because you can't get 0 in the denominator. So the only number that we possibly have that we're looking at for that critical value is 1. So our number line, here's 1, and this is a not defined. It's not a 0, it's a not defined. So what are we looking at? We're looking at something below and above. So if we look at the derivative, what's a number below 1? We could use 0, so you have your test values. Let's use 0, and then what do you get for your derivative? Do you get, or your y value, however you want to think of it, do you get positive or negative? So go up here, put 0 in. 1 minus 0 is 1. I'm just going to use my calculator. And just show it to you. So for our derivative, we're going to have 1 over. So I'm just going to do the in this form, which is fine. So I have 1 divided by 3, 1/3, and a parenthesis. 1 minus our 0 value, all to the power of a negative. Use the negative by the enter. 2 divided by 3, 2/3, times -1. Boop. It is a negative. Didn't really care what the value was. It's a negative. Okay, so we're at a negative right here before. Now, if we look at after, maybe we could use the number 2. Okay, so then 2, I'm going to hit second hand enter, go back up, and I'd have the 1/3. So I would just want a 2 here, and ooh, I get a negative again. So this value, I guess you could put the 2 in. It's going to give me negative. This, when you put in the 0, I get out a negative. So negative, negative, negative. What does that mean when everything's negative? It means it's decreasing always. So we have a non-defined, but it's got to be starting somewhere and just whoop down, down, down. Okay. I think the graph of this one, maybe I'll show this one. So you could always graph it on Desmos too. Oh, I just click on it and then I can get it. Okay. All right, so if we graph the original, derivative is telling me something around the original. 1 minus x to the power of, do that in parentheses, a 1/3 into that. Oops, I did 1/3 there. Oops. 1/3. Boop, boop. There we go. There's our graph. Is it decreasing everywhere? Yes. Do you have one value? Where was our one value? If I put in 1, no, this one. Was it this one? Where was our undefined one? Oh, it was only in the derivative. Sorry, I lied. The derivative was undefined at 1, but the regular one was defined. I was like, it should be a whole. If I typed in the derivative, let me show you what I mean by a whole. So what's kind of cool is if you have an x squared and you do a derivative, you get a line. If you have an x to the third, you're going to get an x squared. So it's going down a power. So they always kind of look similar. But the derivative graphed, not that the graph of the derivative really tells us a lot for our class. I keep clicking the wrong one there. The derivative, it's got a negative on top. All right. What did I have? 1 minus x to the power of 2/3 to the power of 2/3. Ta-da. So you can see where the original equals 0 is a critical value. It can't equal that. So you can kind of see it like goes in at it, but it's never going to have, the derivative doesn't work there. That was at our 1. Okay. There you go. That's the derivative. So I was looking for like a whole or something, and I was just mixing them up a little bit. Okay, so that was more examples. Hopefully those kind of helped you. Yeah, I think that was like the couple tricky ones. You do have a couple economics questions that'll use this as well, but I think you'll be okay. Most of them are pretty basic formulas, and you're just finding the derivative and plugging in a value, or you're finding the derivative and deciding if it's a max or a min kind of idea for that increasing and decreasing. All right.